Okay, so let's see, where did I leave off last time? Well, I still got people in the waiting room. And just for your own future reference for, other classes or whatever with Zoom, if you log in with SSO, when you go to the main page, that will let you automatically get into Concordia Zoom rooms without getting put in the waiting room. You'll be authenticated with your Concordia credentials. It's not a big deal, just you won't get thrown in a waiting room and then have to get admitted. So last time we were talking about more with memory, more with arrays. We talked about cleaning up our own mess. If you remember, we created we've been reminding ourselves that default arrays in C and C++ don't know about their own size. So we decided, hey, maybe a workaround to that would be, hey, let's build a struct, maybe called an int array, that holds on to a pointer to an integer as well as the size, how many elements are in there. And then I can just pass that struct around, and my functions would be able to ask that struct, what's the size? If I scroll down to this guy. So here's well, let me do the print array. Here's fill array that took the struct in, and I knew how many elements were in it because it was the size of my struct. My struct holds two components, the pointer to the int, and then the number of elements that are the pointer to the int array, and then the number of elements that are in the int array. So it allowed me with one variable to pass around that information. So we'll call this a little bit of an upgrade. And I did mention last class, for those of you who maybe have had some of this stuff before, who went and looked at it, there are collection types built into C++ that know about their length. There's things like vectors, and there's actually a more modern array class and things like that. But doesn't matter. This allows us to talk about memory and things like this, and this would be traditional arrays. In more modern languages like Java and C#, if I were to create this array in so what do I have, 100 bucket array in Java, I can say something like int array AR is equal to a new int array 100, and then AR.length would be the number of elements in that array. So Java and C# arrays have encapsulated the ability into the normal array type to report their size. And we're experiencing right now the disadvantage of an older language like C++. And one of the features that newer languages like Java added to C++ for programmer convenience. Okay, now I did mention at the end of class last time that I was going to ask you at the beginning of class today, what can't we do with a struct? So we've created a struct here capable of holding our int array. So it can hold the pointer to where it begins and can hold the number of buckets. But what might we want a struct to do that it can't actually do? Any theories? How many of you are maybe getting a little bit tired of having all these prototype functions up here and then having a whole bunch of implementations down here in main? Not that these things aren't going to exist somewhere, but when we're talking about the main controller for our program, in this case main, we just have a lot of fluff on this single file, and that's kind of becoming a let's call it a problem. As programs get larger and larger and larger, the number of things that we need to kind of keep track of increases, and the more we're going to need to have some level of organization. And that's where objects come in. So we're going to start talking about objects now. And really, objects were born out of the limitations of structs. So objects. Remember that our modern languages like C++, Java, C#, these are object-oriented languages. Okay. Sometimes you'll hear it referred to as object-oriented programming, object-oriented languages, so OOP, OOL. All right. So these are languages that have a facility for creating objects, which can store 0 or more values and potentially do more. And it's that potentially do more thing that's going to be of interest to us. And we're going to see that today. All right, so the keyword class exists to allow us to create an object. Okay. This class keyword is similar to struct. So if we want to create a struct, we have to use the struct keyword. If we want to create a class, we use the class keyword. Now I'm going to immediately start with an organization piece here, but I want you to understand that the stuff I'm about to write inside of a new file could be written inside of this main file here. But one of the things I just mentioned is we're starting to get a big enough program at this point that we might want our stuff to be a little bit more organized. So what I'm going to do is I'm going to, let's see, I'm going to create a new project. So it's just so we're starting from a fresh, maybe I just go to projects. Can I create a new one here? Yep, there we go. All right, so here's a new project. I'm going to go ahead and save this project as, let's call this array object. All right, so I have my my starting main here. So if I go and run this, I have my working hello world. I usually, I need to select C++ as my language. All right. And there's my hello world. I always start with that just to make sure everything I'm doing is currently running. And I have my solid runtime. I'm going to get rid of this stuff here at the top. All right. So now what I'm going to do is I'm going to create a new file. I could actually, let's start with putting it inside of this file just for the sake of argument. Then I'll show you how we can move it outside. So I'm going to start with this a simple class. So we're going to say class call this number container. All right, so there's my class number container. And we're going to be talking about public, private, protected stuff later on. But for right now, we're just going to say everything lives under this this public container, which means everybody has access to it. So let me explain that later. Just leave it like this for right now. So I'm going to say int A, int B. These are two pieces of information that I want to keep track of. All right. Now, from there, I can go ahead and I can store a couple of things inside of my number container, but I have something called a constructor. So let's go here. A constructor is a special kind of method that allows us to conveniently initialize objects. All right, and this will make sense through an example here in a second. Constructors are always named the same as the class. All right, so I'm going to have a constructor here, and I'm going to have this guy take in a int num1 and an int num2. I'm going to show you alternatives to this later. I'm just showing you the basic version of a class for a moment. Okay. Let's see, which way do I'm going to go ahead and do it as a full implementation here. All right. And what I'll do is I'm going to set A is equal to num1. And I'll set B equal to num2. All right, so now I have an object called number container that has a whole bunch of publicly accessible members. What are class members? Members of a class are fields, constructors, and methods. So to answer the question from a few minutes ago, I mentioned that structs have a limitation. They can only hold values. What if I want to have methods or functions that operate on those values and have all that stuff encapsulated inside of my object? So this goes back to when we first started talking about object-oriented languages. And I had the, I probably used the example of the object-oriented telephone, right? Where if you walk into a room and I'm holding up a telephone, all of you can identify it because you know what a telephone looks like. Yet you all believe there's some complex stuff inside that telephone that somebody else created. These are methods, these are abilities that that phone can accomplish given the right inputs. And I can just ask a phone by using the keypad or whatever to dial a number, make a call. I can also answer a phone call on a phone, so on and so forth. Maybe the phone has a built-in answering machine or whatever. Now we're starting to get into older phones, but regardless, classes add the ability to also have functions that operate on your fields. So the fields are the variables that belong to an object. So in my example here, A and B are fields. For no good reason, I'm creating this object called number container, and it's just a little container that's going to hold two numbers. For no good reason other than I want to create a simple example for introducing objects. We'll create something more interesting here in a few minutes. All right, so I'm going to hold two numbers. A constructor, as I already pointed out, and you could have more than one constructor if you want, but we're not going to cross that bridge yet. So a constructor allows us to initialize the starting state of an object. All right, and what do I mean by that? Here's the constructor. It matches the name of the class. I'm going to say that my constructor takes in two integers as parameters. I am purposely, for right now, naming these guys different than the variables here so that this works. And what I mean by that is if I say int A, int B here, and I say A is equal to A and B is equal to B, what I'm trying to express is I want this version of A to be equal to that version of A, and this version of B be equal to that version of B. And we do have the ability to do that. Let's foreshadow it a little bit here. We can say this arrow A equals A, but for right now, we're just going to say out of necessity, since we don't know any better, I need to name these variables something different. And I'm going to go ahead and say this would be considered poor programming practice. When you create a variable, you probably want that variable to be meaningful, not that A and B are overly meaningful names. Num1 and num2 are more meaningful, but typically you would name your fields something, maybe we call this guy the first number, and we call this guy the second number. All right. And then we're going to set the first number equal to num1 and the second number equal to num2. So these are better variable names, let's say. So we're going to say these are the appropriate names for these variables. I'm storing two numbers. What are they called? They're called the first number and the second number. Okay. But because we don't know any better right now, for my constructor, in order to initialize those values, to give them a starting value, I need to have two numbers get passed in to set them. Well, out of a necessity at the exact moment, I need these two numbers to be, the variable names to be different than these. Why is that? All variables resolve to their most local definition. All right. So every single time that a programming language sees a variable, it's going to try to determine what variable are you talking about. It's going to resolve that variable. All right. So when I say the first number here, the first place it's going to look is in the local scope. It's going to say, do I see a variable defined here called the first number? No. Then it's going to look in the parameter list. Do I see a variable defined here called the first number? No. Then it's going to bounce up to the next scope it has access to. We can think of this similar to the global scope we've been talking about. So this is the scope owned by this object, and all methods and constructors inside of this object have access to these fields. So yes, these are plain Jane variables, nothing special about them from our perspective, but in the object-oriented programming naming conventions, these are called fields, okay? So when I say the first number, it's gonna first look here, not find it. It's then gonna look here, not find it. Finally, it's gonna look in this scope and it found it. When I say num1, it's going to look here, not find it. Then it's going to look here and find it. All variables resolve to their most local definition. It looks locally first and then gets a little bit more distant as it can't find things locally. All right. So if I had called this guy the first number, for example, now when I try to resolve this variable, the first number, it's going to think I'm talking about that dude. All right. But I'm still advertising this is bad programming practice, and we'll fix it here in a little bit. I'm just starting off with this as a simple example, although I will say this is an extremely common, what I would call poor programming mistake. Even professional developers don't understand this concept because I showed you a minute ago that this keyword, that's something that's going to be extremely important for us. And until we understand what it means, which a lot of professional developers have a tough time wrapping their mind around it, even though I'm just like pointers, I'm trying to tell you is a pretty simple concept. And hopefully I'll be able to drive that point home. All right. But out of necessity for right now, since we don't know any better, I'm going to purposely name these variables different. That way we can let the variable resolution rules play out in a way that we're already comfortable with. Variables resolving to their most local definition, and now we're just dealing with scoping rules. All right, so for right now, let's just leave number container alone. And I'm going to come down here, and I'm going to go ahead and I'm going to create a number container pointer called NC. And this guy is going to be a new number container. I'll pass it 5 and 7. I'll create another number container NC2, and this is a new number container 13 and 12, for example. Let's see. Right now it's got standard IO. We usually use IO stream. Then we use namespace standard. This is just our normal input output stuff we've had in all our programs. Old style C uses standard IO, which gives us a function called printf to display stuff to the screen, and scanf to read stuff in. Whereas C++ introduced IO stream, so we use C out and C in. So this is nothing new. This is me just updating the program to do our IO the way we've always done it. So I'll go ahead and I'll do a C out NC and a C out NC2. Go ahead and run this dude. And we see that we have 2 crazy memory addresses, just like we've seen a whole bunch of other times, right? All right. Now, just for the moment, I'm going to say NC the first number, and I'll say NC2 the second number. We'll run that guy again. Ooh. Oh, sorry. I need to cheat a little bit here. Pretend like you understand what that means for a second. All right. So let me write it in the way that is consistent with what we've done so far, so you can understand why. So I can say that. And I can say that. Just run this real quick. All right, let me explain why this works this way. And this is nothing new. So I'm trying to write stuff in a way that's consistent with the way you've already done stuff. All right, so this guy right here is, well, this guy right here is a variable. What kind of value is this variable built to hold? Remember, we're dealing with a strongly typed language. He's built to hold a number container pointer. What's a number container? He's this dude up here we invented. Okay. So very similar to a struct. All right. So if we were to throw a struct up there, we would say struct number container. Here, we could even do it here. We could say struct number container struct. And then we can say int the first number, int the second number, like that. And then we can do something like struct number container struct NCS. Then we can say NCS dot the first number is equal to 14. NCS the second number is equal to 11. And then I can say C out NCS dot, let's just say the first number. Whatever. All right, so the first number for NCS is a 14. The second number for NC2 is a 12. The first number for NC is a 5. Oh, and L. All right, so those are three values. So right off the bat, as we have it written right now, the way I'm using my two objects here, well, my one object, but I have two instances of this object, is pretty much identical to how I've historically been able to use structs. I have a struct capable of holding two pieces of information. How do I use them? I define a variable of type struct, and I set those two values. Just like I have an object here capable of holding two pieces of information. How do I create it? I create a variable of that type, but I use the constructor to set those two values. I'm passing 5 and 7 in for num1 and num2, which get assigned to those internal values. So right off the bat, if you see nothing else, we see that at the very least, this is a more convenient syntax for creating struct-like beings, as opposed to here's a struct, which required me to set those values separately. All right. So right off the bat, hopefully you see, okay, this is a little bit better than a struct, even if it's just from a convenience perspective. All right. Now, when I come down here, let's cover what this guy means. All right. So what is NC? NC is a variable. He's a variable of what type? Of a number container pointer. Okay. What's a pointer? A pointer is a memory address. And we saw that a few minutes ago. I printed out NC and NC2. We saw two memory addresses. Okay. Now, what lives at each of those memory addresses? What lives there is an actual instance of number container. Okay. So what lives there is the actual object that we've created. And this goes back to what we talked about last class. I've mentioned it several times with the whole pass by value versus pass by reference thing. You know, and I use the example of a party. You know, if you're having a party tonight at 8, you don't hand me the house and tell me to open the door at 8. Instead, what do? You say, here's where you can find my house. Here's the pointer. Show up to the house at 8 p.m. and you're at the party. All right. So what am I storing inside of NC? I'm storing the address of this instance of number container. So that's going to be like the street address. Where can you find this in the computer's memory? All right.
Why do you have the word new there?
Yep, I'm about to answer that. Yeah, but good question.
Oh, okay.
So the new keyword, this guy, let's put it on a slide. But you're right where you should be thinking, because that's the new guy. New keyword. New is like I like to think of him like a real estate agent. His job is to go and find memory. Well, his job is to go and ask the operating system for memory. You can think of this like a updated malloc. So we used to say memory allocate to get some memory. Now the more updated word is new. And you'll see that that new keyword carries through to languages like Java and C#. Basically, all of our modern programming languages use the new keyword when we want to create new memory. But now the difference here is malloc allows us to specifically ask for some number of bytes of memory. New allows us to ask for enough memory to store whatever we are building. This is an automated process. That is to say, we didn't have to understand how big a number container is. Number container is defined up here as this class. It does have a size. All right. And there's a way when you take the 470 class and we, language theory, we talk about building programming languages. One of the things you're going to learn about is how do we implement the idea of objects into a programming language? Okay, so you're going to be learning the under the hood stuff. So at the very least, we're storing 2 integers. So right off the bat, that's going to be 64 bits of memory, right? 8 bytes of memory for those 2 guys. Then you got this constructor, and we're going to see here in a few minutes, we have some functions we can add to that guy. So pretty quickly we can say, oh, well, maybe a number container is, in our case here, let's just make up a number and say it's 100 bytes. I'm just pulling a number out of the sky. Okay. We didn't have to know that with the new keyword. With the new keyword, we just asked the operating system, give me enough memory to hold one of these dudes. Okay, to hold a number container. So we're going to call this an immediate upgrade in requesting memory. That isn't to say that malloc is completely unusable, and sometimes we're going to want to use malloc. Sometimes we're going to need to use malloc. We're probably going to have an example of using malloc here shortly, because at this point, we're still going to be working with int arrays if I'm heading in a direction of using an example of an int array here. So we're going to still allocate memory for that int array, presumably. Okay. So now that's what the new keyword is for. But any way you cut it, this guy is a pointer type. I have a variable NC that is capable of holding a number container pointer. I have a variable NC2 capable of holding a number container pointer. So my question for you right here is just what I have highlighted. What is star NC? When we deal with pointer syntax and we use the asterisk, what am I talking about when I say asterisk NC? I read it as star NC. What am I actually talking about right there?
The value of NC.
Yeah, the value that lives at the memory address that NC points to. Okay. Now, what kind of value lives at the address that NC points to? A number container. An instance of our number container. The actual object. If I hand you, going back to our house example, if I hand you a little piece of paper with my home address on it, okay, while you have that piece of paper, so if I can, we'll just make something up here. House pointer, call this guy Mike's house, and this is a new house. I don't know. Let's just say it's 3,000 square feet, whatever. All right. If I hand you this variable Mike's house, this guy holds a memory address. All right. He holds the address where my house lives in memory. When I say star Mike's house, now I'm talking about the actual house. I've arrived. I followed the directions that my GPS told me to follow, and now I'm sitting in your driveway. I am at the house. So star Mike's house is the actual house that lives at the memory address stored inside of the variable called Mike's house.
So is new number container like a pointer, or is it like an I don't know, like what?
Well,
an
new
object
creates a
or-
memory address. So we've created the don't try to make this too much of a new thing, I guess, pun intended. New returns the same kind of value as malloc does. It gives us a memory address. We just have to provide it with less precise information. Malloc, we had to tell it exactly how many bytes we want to ask the operating system for. New figures out the number of bytes that are required to hold our object. So new does it for us. But any way you cut it, the value that new returns is a memory address, which is just like the value that malloc returns. All right. So what's stored here in NC is a memory address, just like any other memory address. All right. It just happens to be a memory address that points to something of type number container. This just happens, assuming there's an object we wrote called house, which we have not written it, but just for my example here, Mike's house holds a memory address of where the actual house is in memory. But the variable Mike's house holds that address, not the house itself. It tells us where we can go in memory to find the actual house. So asterisk Mike's house is the actual house, as opposed to just the variable Mike's house, which is the address of the house. Because the type of Mike's house is a house pointer, not a house. Now, all this stuff that we're talking about right now, this actually isn't new stuff. This is stuff that we've already been learning about recently. I'm just now connecting it to objects. Okay, a pointer is still a pointer. It's a variable that holds a memory address. And when you put an asterisk in front of that pointer, it's still like this. This still says, give me the value that lives at that memory address. Make sense? Now, so let me just comment these out for a second here. So now getting back down to the syntax. For starters, we're going to say this syntax seems a little bit inconvenient in that, okay, I needed parentheses here. I asked you, what did star NC mean? Just like star Mike's house meant the actual house, star NC means the actual number container that lives at this address. Star NC2 means the actual number container that lives at this memory address. So right here, when I have parentheses, star NC parentheses, that boils down to an actual number container. And once I'm actually at that number container, I can then ask him for the first number. Once I'm actually at this number container, I can ask him for his second number field. That makes sense? Notice we did not need the star for NCS. Why? Because NCS is not a pointer. NCS is a struct number container struct. If I wanted him to be a pointer, I would have had to say that. And if I had to say that, then I would have had to do this. And I would have had to do this. So syntax is nothing new. We're just applying it to different stuff. Okay. So that's what this syntax, as we have it written right now, actually does. Have I removed all my errors from this now? So there's my 5 and my 12. That's from these two lines. That's saying NC holds a memory address. Give me the value at that memory address and ask that dude for his first number field. NC2 holds a memory address. Give me the value that lives at that memory address. Follow, once you're there, ask him for his the second number field, print that out, so on and so forth. Now we're going to say that we could always use this syntax if we want. There's nothing wrong with this syntax, but we can say to ourselves, you know what? it's a little bit inconvenient to have to throw some parentheses and stuff like that in there. And I'm guessing that the reason that we're using objects here and the reason that there are entire programming languages classified as object-oriented languages, that this kind of thing is something that we might be doing fairly often. Okay, this is going to be a pretty common ninja move that we're going to do. And given that, maybe we don't want to have to do this this full parenthesis star variable name close parenthesis in order to ultimately use dot notation to call one of his fields or call one of his functions or methods, which we'll introduce here in a few minutes. So we do have an alternate syntax, something I call syntactic sugar. That NC2 arrow is equivalent to what I did right here. This says dereference the variable and then call one of its members. So if we add a slide for that guy. Maybe we can do it by an example. So if I have number container pointer NC is equal to new number container 1, 2 star NC dot the first number NC the first number. These two things are equivalent to each other. This arrow says dereference this variable, then put a dot after it and call whatever member you've done. So it's syntactic sugar for what I'm doing up here. Dereferencing and then using dot. So you never have to use this arrow if you never want to, but you're going to want to in C++. Now, something that came up after class, so and it's something I've been referencing several different times, directly and indirectly, I guess, is our more modern languages like Java and C# have made improvements to things that C++ introduced to make life easier for the programmer, okay, to give us better quality of life. We started off today by saying, right off the bat, in Java, arrays know how long they are. Magical. Saves us a whole bunch of headache. That when I create an array, it remembers how big it is in Java. Seems like something very trivial, but wasn't included in C++. Hindsight's always 20/20. All right. Similarly, in C++ is when we first really introduced mainstream objects. C++ is not the first object-oriented language. I think that's typically credited to a language called Smalltalk. But regardless, when objects came out in C++, the thought was, oh, this syntax is no big deal, not a problem. Well, as the problems we started solving, the programs that people were writing became larger and larger and larger and more complex. Well, at that point, we said, you know what? I'm having to write this crap pretty often. So let's give ourselves a zero syntax. C++ at least added that. Well, in Java, they said, you know what? Every single time I'm working with an object, I'm having to dereference that variable because objects always hold memory addresses. We always build objects with the new keyword. The new keyword's our real estate agent who goes and gets us a memory address. All right. So the value of the variable of an object is always a memory address. And in a language like Java, we would say number container NC is equal to new number container. That's Java. C++, Java. Notice the difference here is in C++, we have a special syntax saying, I'm creating a variable capable of holding the memory address of a number container. In Java, I'm creating a variable of type number container, but I promise you that this guy only knows how to hold memory addresses. So Java said, you know what, if you're using objects and the value stored in that variable is always a memory address, why should the programmer write some extra crap over here just to label it as something that it's always going to be? So in Java, they've taken away the special syntax for pointers, but this guy is still a pointer. But then in Java, when I go to write this, I can say NC dot the first number. So this is Java, this is C++, because, and this is C++. Both of those are C++. This is Java. Why? C++ makes us specifically dereference the memory address and then call the field, where Java says, you know what, this is always a memory address. So I'm going to trust that whenever you say NC dot, you want me to go ahead and dereference it. You're not talking about the memory address. You're talking about the thing that lives at that memory address. So with that in mind, Java just says, I will just always treat this as dereferencing. That way you don't have to have this special extra little syntax to make this life a little bit easier. All right. So we're seeing an example there of how Java made life a little bit more convenient for programmers by taking away some things that programmers commonly had to do in C++, but always had to do it the same way. They always had to do it the same way in C++. There was never an example when you were using objects that you didn't dereference the variable in order to use the abilities of the object. So they were just torturing you by making you write all this extra syntax. But understanding what that syntax means is important. Okay.
Wait, so
Go ahead.
So was number container like without the star? Wait, what was that originally? Like a class? I forgot. Or wait, oh, so those two things are both objects.
Yeah, these are identical. This is
Okay,
the
so
same.
number,
If I were writing the same line in Java, I'd write it this way.
so number container, what was that? I forgot what you had that. Was that a class or?
Yeah, that's a class back over here. That's the guy we are inventing as our little example.
So when you make a variable and then have it the type, like its type is a class, then that makes it an object.
Correct. Yep. When you use the keyword class, you're building, you're describing the blueprint for an object. You're creating an object. You can think of this as kind of like blueprints for building a house. When I say class, I'm describing what number container objects look like. I'm saying number container objects hold a couple of pieces of information here. These are the fields, and here's the constructor for that guy. We will be adding to this here in a little bit, but it sounds like you understand what's going on. Yeah, that a class is an object. That's where your mind should immediately go when you see the word class, that we're describing an object. And this is where we're creating instances of that object. Now, let me go ahead and just quickly add because I've used that word several times, but let me just give some instance. An instance of an object is an actual value that has already been created of that object type. If I say an example, the blueprint for a house would be a class. An instance of a house would be an actual house built using that blueprint. So if you go into one of those housing developments where every single house looks the same, the contractor, the constructor, the guy who constructs the houses, he would have a single blueprint, and he would use that blueprint to build 20 houses that were just like each other structurally, but they held different families and different furniture and all sorts of things like that. Each one of those houses is an instance of that blueprint. So we describe what our object looks like once using the class keyword. Then we use that blueprint to build instances of that object. Like in our code here, we wrote the blueprint one time. This is our blueprint. And then we use that blueprint to build two separate instances. So when I say an instance of an object, we're talking about the actual object, not the class that described what that object is if it had been built. You know, if you have a blueprint laying there on the table for a new housing development that hasn't been built yet, you have the plans for building a bunch of houses, but you haven't actually created any instances of those houses yet. All you have is the class. You have the plans for how to build one, but you haven't built them yet. All right. So just showing this as an example here, you can see how Java made your life a little bit easier by taking away this syntax of a pointer. We no longer have the asterisk here. Java just knows, oh, you're dealing with an object, you use the new keyword, this dude holds a memory address, I'll go ahead and remember that for you, rather than you having to dictate that's what he's holding. Similarly, in Java, it's going to say, hey, I remember that this guy held a memory address. So when you say NC dot here, I'll go ahead and translate that into what you mean. And what you mean is follow that memory address to the actual object and then call the first number. What you meant is this. Give me the value at that memory address. C++ makes us do that. So this is C++. This is C++. Convenience syntax. I often call this syntactic sugar. Okay, so these two lines are identical. This is the way C++ has allowed us to make this a little bit more convenient. You see in Java, they've just dropped the whole star-based syntax and just said, look, it's a memory address. I know what you mean. I'll deal with it. So Java does a lot of stuff for us under the hood, which explains why I use C++ in here. C++ allows us to explain this concept so that when we get into Java, we can appreciate what it's doing for us in a little example like this, or with arrays knowing how long they are. Okay. So you're really supposed to be frustrated with C++ at the moment. Like, isn't there something better than this in terms of convenience? The answer is yes. And then if you follow it up by asking, well, why didn't they make it better before? Well, the answer is they didn't know they needed to make it substantially better, because when that language was invented, the kinds of programs that programmers were writing were significantly simpler than the programs, or at the very least, significantly smaller in size than the programs that we're writing today. And you might also say that the average programmer back in the early days of C++ was, I don't want to say much more geeky, but they were already dealing in a world where they were building computers with soldering irons and stuff like that by hand. Something like this was not that big of an inconvenience to them, right? Because if their computer was on the fritz, they'd literally open up the case and get in there and start melting wires. That's not how we operate now. Now several of you have built your own computers before. And what do? You buy a whole bunch of individual parts and they all click together like Legos. All right. So, we just live in a different world where we expect more convenience, and things like this kind of tick us off because it seems like, why isn't there something better? Why do we have running water to our houses right now? Because we don't want to have to walk down to the creek to bring back buckets. Things that we used to have to do that we now take for granted. This is the punchline. All right. So this arrow syntax here allows us to make one little step towards having a little bit more convenience. All right. So these two lines do the same thing, and we saw that we get numbers out of that. Okay. Here's my use of a struct. But notice that building this struct took 3 lines. Define the variable, set the 2 values of that struct. What some people will do is, if they're going to be making lots of structs like this, they'll actually just write a function, maybe called create number container struct, that they pass the 2 numbers to, and it just returns the struct that they built this way. So they didn't have to waste 3 lines of code all over the place in their program. Instead, they just had it all housed inside of a single function. And whenever they needed to create a new version of that struct, they just called that function and it spit out the struct that they asked for. So we would almost generate what we've done right here. Okay, so objects immediately start giving us some benefits. All right, so questions about this so far? All right, so now we're going to take it a step further. Going back to our slide, members of a class. Our class right now has 2 fields, the first number and the second number. Our class right now has a single constructor that takes in 2 numbers and sets those 2 fields to those numbers. You could do other things in there too if you wanted to. If for no good reason, I wanted my constructor here to say for int I is equal to 0, I is less than 10, or whatever, I is less than 20, I plus plus, and then C out hello world. Now, every single time I build a number container, I'll set the 2 values and then spit hello world to the screen 20 times. For no good reason whatsoever. Just that's what the constructor said to do. So there's my hello world. So we should have had 40 of them show up on the screen because I built 2 separate number containers. I called the constructor once, I called the constructor a second time. Each time, it set the numbers that were passed in, and then it printed out hello world a zillion times. So nothing says that a constructor only sets the fields. The constructor can do whatever it means to you to initialize your object. All right. So now we're going to take it a step further, and we're going to go ahead and say, well, why don't we give an ability to my object? Why don't I create a function, maybe called add nums, and we have this guy return the first number plus the second number. So now, not only does my object remember a couple of fields, not only does he have a constructor for initializing him when I first create him. Constructors exist to support this syntax right here. That's when constructors are called right there. That's the only time constructors can be called, is following the new keyword. But now I've added an ability, a method to my object. So now number containers also know how to add their numbers together. So now I can say cout nc arrow add nums. And that will add NC's numbers together and return the value, because that's what add nums does. Add nums, no, all variables resolve to their most local definitions. So the first number, it's going to look here first, not find it. It's then going to look here, not find it. Then it's going to bounce up to the next scope he has access to, which are the fields of this class, and he's going to find it there. And the first number will have a value. So add nums takes the first number, adds to it the second number, and returns that as an int. Nothing new. This is a function like we've written before. We've just put that function inside of our class blueprint. So now I can say NC, I want you to add your nums. And I can also say NC2, I want you to add your nums. Okay. So for NC, adding these numbers together should get me a 12. This should get me a 25. So there's my 12 and my 25. I called upon that ability. All right. Any questions about that? Now, as you might imagine, I kind of advertised at the beginning here that as our programs get bigger and bigger and bigger, we might start we might start seeing examples where, you know what, it would really benefit me to store some of this logic in separate files. You know, like maybe I have a file that holds all the stuff about number containers so I can just use it later on. So what I'm going to do is I'm going to copy the contents of this class. Well, I'm going to cut it, so I've remembered it. I'm going to go ahead and create a new file. Call it numbercontainer.hpp. You can actually name it whatever you want. This is just common naming conventions. In C, they were .h files. They were header files. In C++, they're C++ header files. All right. So this is more naming convention. You name the file .hpp. And inside of here, I just went ahead and put the information about my class. Didn't change a thing, left it all in there. I do need to make sure that I'm not, if I were doing any cout stuff in here, for example, I would need to make sure that I included IO stream at the top and all that stuff. But I'm not doing any of that stuff right now. So what I have in here, C++ knows about. Then what I would do is at the top of main CPP, I would say include number container .hpp. Notice I've put it in double quotes. Double quotes effectively says, I made this, look for it in the current directory. Whereas these angle brackets up here, IO stream, this is, I'm including something that comes with the collection of C++ libraries. This is not something you should expect to find in my local directory. This is something you should expect to find in the place where C++ libraries are stored, whatever that is for that particular operating system. All right, so important distinction, the double quotes around this say look locally. So I've created a file called numbercontainer.hpp that has the exact same code in it that I had in my other file before. And now what I did is I just said include the contents of that file here. All right. So important, important piece. Go ahead and run this again. See, it still works. It knows about number container objects. How? Because I've included the header file where that guy is defined. Now, taking this a step further. Well, just any questions about that? What we've written right here would very much be the way it's typically written in Java. Java, when you define classes, you typically write the entire class like we've done here. And there's nothing necessarily wrong with that. I would say that commonly the C++ approach to this would be to have another file called numbercontainer.cpp. And then what I would actually have, copy this guy. I would include number container HPP at the top of this. And then I'd let me just create it here real quick, and then I'll explain what's going on. Oh. All right. So I promise you, all of the same logic is written. But now what I've done is I have a header file. And when you look in the header file, what do we see? We effectively see a list of the abilities of this class. This class remembers two fields, has this constructor, and has this method. So if we wanted to, we can label these. We can say fields, constructors, methods. And I advertised here that the members of a class are fields, constructors, and methods. So, well, yeah, whatever. Reusable chunks of code owned by the class. Same thing as functions. So now when you look at the header file, you're really getting at a glance kind of a feature list of this object. Then when I go into my numbercontainer.cpp, I'm including this guy here. But notice that I'm actually implementing the constructor, implementing the add nums. I'm writing all the logic inside of this file. So you imagine for a pretty complex object, you're going to have, you know, maybe 1,000 lines of code in here. So now you can glance at the header file and in a fairly small footprint, see what are these objects capable of and how do they work? And then in a whole nother file is where we contain the actual logic of it. So this is, but the only thing I had to add is I had to say contain number container like this. I think, I don't know if I can do it in this setup on here, but I could have done using namespace number container, and then I wouldn't have had to do that. but this is the traditional way of doing it. I've said I am implementing something owned by that object. I am implementing something owned by that object. So now back in main. Oh, sorry. Small little copy and paste issue. The return type comes before that guy. So this guy
Do you have
returns.
to do the double?
Yeah.
Do you have to do the double colon thing every time?
You do, if you're writing it this way. And if you remember earlier in the course, when we first, if I'm out here and I don't use namespace standard, if I got rid of this guy, anytime we did a C out, I would have to do that. Standard : C out. I would have to specify who owns that that function. All right, so we see this still works. Now you can choose the way you want to write this. I would strongly encourage you to, at the very least, implement your classes inside of a header file. If you don't want to split it into two separate files like this, I would say you don't have to. It's okay to just put it in a single file. That is definitely the way it would be done in modern languages like Java and C#. But if you see value in being able to say, what can number containers do? And you can just glance at the header file and see this. And then you can go over to the CPP file and see how it's implemented over here. I think there's value. Now for your homework,
Wait, I had a question.
go ahead.
So are you able to do more than one constructor per object?
You can, but I would say for right now, don't think about that. But yes, you can. You can have
Okay,
more than
cool.
one constructor with a different number and or type of parameters.
Okay.
We'll be talking about that concept soon. So create a class named dice. A dice object holds a number of sides. A dice object has a roll method that returns a random number between 1 and the number of sides for that instance of dice. Implement the class, the constructor, and the roll method, and test it in main by creating a 20-sided, 10-sided, and 4-sided dice, and having each one roll. Submit the link to the code and the self-assessment. And what I'll do here is I will save this and I will share. So I'll give you my current setup as a starting point. And then, so this shouldn't be that big a deal. This should be a fairly short program as long as you followed what we did today. All right, so this will be due on Tuesday. Questions, comments, concerns, bribes?
So
For the
you go.
for the tech talk tonight, where is that located?
It's in, and Emily had put it up on Slack. It's in Pharmacy 008. So it's in the main
Okay.
floor of the pharmacy building, one of the big lecture halls.
Okay, I
We
just
were
thought I'd
gonna
let
be
you
in
know
that,
that.
we were gonna be in the auditorium, but we got bumped because of the play. They extended the play.
Okay,
Yes.
yeah, I just
Yeah.
thought I'd let you know that I won't be able to come for like the whole tech talk just because I have something else going on.
Sure, that's fine. Come for as long as you can. This is one of our alumni. This is the guy I've mentioned in class who travels around the world. Every 3 months, he moves to a different international city and he works remotely for a company in New York. So he'll, he's a digital nomad and he does full stack Salesforce development. So he'll tell you about what he does and you can ask him questions about, what's it like living in all these different countries with time zone differences and stuff, still working for a company in the US.
So like a class creates an object, right? Like a class isn't necessarily an object, like, or
A
is it?
class is the blueprint. So if you were
The class is
standing at the construction site and the guy had the big piece of paper with the plans for how to build a house, that's the class. The class is that giant piece of paper. Not until you actually go and create instances of the houses, build the physical house using that blueprint, do you have instances of the house. So you have a single blueprint, that's the class, and then you can have multiple houses, multiple instances of that house where you use the blueprint to create it.
Okay, that makes sense.
Okay. Anything else? Okie dokie. Well, I will see hopefully all of you tonight.